Hi 8th grade, we're going to get started on lesson 2, session 5. We are going to be talking about using single rigid transformations in the coordinate plane. I really like this example, it looks like so much fun. So I love trying to find coordinates. Coordinates are so fun to me.
Teachers, please release the 11th and 12th graders to go to the gym.
Sorry, there's an announcements going on right now at school.
To the gym. Thank you.
Okay, so now the announcement's over. Okay, so Aisha rotates triangle X, Y, and Z clockwise around the vertex Z. Okay, so Z is its little pivot. What are the coordinates of the image X, Y, Z prime? Look at how you can show your work using the coordinate plane. So she rotated it around Z, so Z was the pivot, okay? The shape rotated, so now we have the new shape over here. And now, what are the new coordinates? So I'm just going to go ahead and go like this. X prime, and I'm going to tell you what X prime's coordinate is. It looks like it goes over 1, 2, 3, so it's a positive 3. And then it goes up 1, 2, 3, 4. Okay, and then Y prime. I'm going to go ahead and get my eraser and erase this stuff. Y prime is over 1, 2, up 1. And then Z, do you notice how we didn't call it Z prime right here? That's because it's still sharing Z. It didn't move. So Z is negative 1, up 1. It's a positive 1. Okay? All right. Let's go ahead and do number 1. Darius transformed TUVW to form its image TUVW prime using 2 different transformations. Identify the single transformation he used for each of these. Okay, so let's look. I'm looking at the first one, and it honestly looks like he just translated it up here. Like it looks like it just slid. And I know that because if I were to actually translate this and then move it, do you see how the everything lines up? T is where T is, W is where W is, U is where U is, V is where V is. That looks like a translation to me, okay? So the first one is a translation. And it looks like it went, so if I go from U to U, it went up 1, 2, 3, 4, 5, 6. So I'm going to say it's a translation of up 6. Now let's look at this guy. I moved him over here so I could see because it's still TUV. But if I raise it up here, the T and the V are okay. It's the W and the U that have changed. Okay? So here's what I'm noticing. I think this is a reflection. Because if I were to reflect it right there, U, if I folded it, U would land on U, W would land on W, T would land on T, and V would land on V. Okay? So I'm going to say this is a reflection. And then what is the line of reflection? It looks like it's the x-axis. Okay. Number 2. Point D is shown on the coordinate plane. Plot the image point for each single transformation of point D. So this is a little different. We got just a point, not a shape. So I want you guys to make point D, I'm looking at A. I want you guys to make point D reflect across the x-axis. Okay, so here's our line of reflection. Count how many I have to do to get from D to the line. 1, 2, 3, 4. That means I'm going to now reflect it up 4. 1, 2, 3, 4. Here's our new D. Oh, and they want us to name it A, not D, and I know that because it says image A. So I'm going to say A, and it's A. It's not A prime. It would be D prime if it was, but it's A. Okay. What are the coordinates of now A? Let me go ahead and erase my markings. Ooh, without erasing A. What are the coordinates? It is back 1, 2, 3, up 1, 2, 3, 4. So the coordinates are -3, 4. Okay? now we're going to take D, and we're going to translate it 7 units to the right. Okay, I'm going to erase my little markings. Boop, 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 boop. 7 units to the right. So starting at D, 1, 2, 3, 4, 5, 6, 7. And that's our new shape, B. Erase my marks. Let's go write down what B's coordinates are. Looks like it went over 1, 2, 3, 4, and then down 1, 2, 3, 4. So 4, -4. Okay, now we're going to take D and we're going to rotate it 90 degrees counterclockwise around the origin. Okay, this one's a little bit trickier. Go and erase. Okay, we want D to go 90 degrees counterclockwise. Now here's the thing. It's going to land, hold on, 90 degrees counterclockwise. Counterclockwise means that way. I was going the other way and I was really confused. Okay, ready? So it looks like D is -1, 2, 3. So D is -3, 1, 2, 3, 4. So I'm guessing that C, the new D after I move it counterclockwise, is going to land somewhere near 4, 3. We have these really, really interesting rules about rotations. I can't remember if you guys remember that from the beginning of the chapter, but it's where these two things flip, right? So 4 would go where X is, 3 would go where Y is, and then I believe it's just the X that changes its sign. So the new coordinate would be 4, -3. We'll have to practice that a bunch. Number 3, triangle H and its image H prime are shown on the coordinate plane. What single rotation maps H to H prime? To me, that definitely looks like a rotation. It does not look like it slid or flipped or anything like that. So let's go through the answers. Is it a 90 degrees clockwise rotation? Clockwise would go this way. H didn't go clockwise. It went like this way, if anything. Or if it did go clockwise, it went way more than just 90, right? 90 would be like that it landed over here somewhere. Okay, so it's definitely not A. How about 180 clockwise? 180 means it would be exactly in a straight line away from it, so it'd be over here. No, definitely not B. How about 180 counterclockwise? So same thing, even if it was counterclockwise, it would still be in a straight line from itself over here somewhere. Okay, so nope, that's not it. A 270 clockwise rotation around the origin. Let's see, clockwise, this would be 90, 180, 270. I think D is the correct answer. But now, Haruko chose A as the correct answer. Why do you think she got that? Do you think maybe she didn't realize it said clockwise instead of counterclockwise? Because if this would have said counterclockwise, I think that she would have been correct. But since it's not clockwise, it's not counterclockwise, it says clockwise. That's why she's wrong. So I'm going to say she probably misread clockwise for counterclockwise. All right, number 4. Figures A through G, so all of them, are images or copies of figure W. Which figures can you not map figure W onto using a single rotation around the vertex? A translation, a reflection, or across the X or a Y, select all that apply. So basically, I can make W fit on almost all of these by doing a single rotation or a translation or a reflection, except for some. Now A looks like it was a reflection, on the y-axis, so that's good. We like this one. Figure B looks like it could have been a rotation, and it landed right there, so I like B. Figure C, if I were to rotate this, it would not land right here. It would still look like B, and would B land like C? No, it would probably look more like this, okay? So C is not something that W could have landed on by doing a rotation. Let me get rid of my markings here. Okay. We liked A, we liked B, we don't like C. I mean, we'd have to circle it because that one doesn't work. Figure D. If I were to keep rotating this, keep rotating it, keep rotating it, keep rotating it, eventually it would land there. We like D. How about E? If I were to keep rotating, keep rotating, keep rotating, keep rotating, I believe it would land on E nicely. So I do like E. How about F? If I were to rotate this, rotate this, rotate this, rotate this, it would land on F. G, if I were just to pop this down like that, it would not land on G. Let me show you. Let me zoom in. If I were to move this down, do you see how this would be flat with the ground? But then this would be taking off an angle like into here. It'd be like that. So it would not land on G nicely. Don't like G. Okay, so C and G. Number 5. 5 figures are shown in the coordinate plane. Tell whether each statement is true or false. A. Figure B is a reflection of figure A across the x-axis. Figure B is a reflection of figure A with the x-axis being the line of reflection. No, the reflection line would be like right in here somewhere. So that's false. Okay, figure C is a translation of figure B 4 units down. So here's figure C, here's B, and did B go 4 units down to get to C? So let's start from this corner and go to this corner. 1, 2, 3, 4. Yes, that one works. Okay, how about figure E? Is figure E 180-degree rotations of figure C? E and C. So it is 180 degrees. That's good, because I can tell it's directly across from it. And if I were to keep rotating, keep rotating, keep rotating, keep rotating, unfortunately, I think the shape would be more like this. Even though it like lands nicely, like where it should land, I don't think it would be in the, it's not like orientated right. So that's false. Okay, figure A is a reflection of figure C across the x-axis. So they're saying x-axis is our line of reflection for A and for C. No, that's not correct, because look, this dot is only 1 away, whereas his little partner over here is 1, 2, 3, 4 away. So that is not a reflection. That's not the reflection line, at least. Okay. Boop. Figure D is 180-degree rotation of figure B. Okay, so B and D are directly across from each other, so that's good. That means it's 180 degrees. Now, if I were to rotate B, that would land up there. This looks like it would land perfectly right on top of D. It would look just like that, so that is true. Okay, figure E is a reflection of figure B across the y-axis. So this is the line of reflection. Looks like from here is 2 points, and from here it's 2 points. So yes, that would line up nicely if I were to fold it there. Okay. This is a long lesson, you guys. Alberto draws figure EFGH in the coordinate plane. He rotates EFGH 90 degrees counterclockwise. So going this way, 90 degrees, it's going to land up in here somewhere. Okay. From vertex E, oh, so E is the pivot. Ooh, nice. And he forms the image EFGH prime. Draw the new image, and what are the coordinates of the new image? Okay. So if I were to rotate this 90 degrees, it's really hard to just eyeball it and be like, I think that's about 90. But what's nice is we are pivoting on the E, okay? So we could just kind of like guesstimate and say, well, it kind of will look like something like, something kind of like this. We could just guess and say that, but I think the best way to solve this one is to write down the coordinates and then just change the coordinates. So we don't have to write down E because E is going to be the same, right? E won't change. E will still be over 1, down 1. But now let's look at F. F's coordinates right now are over 3, down 2. Okay, and what we learned, let's see, F is down 3, right? Over 3, down 2. Okay, and then the new F should be 2, 1. Let's see, F would be here, and that is 2, 1. Man, I really am not a huge fan of rotations. Maybe in class what we'll do is we will practice these rotations and see if there's any cool little tricks we can learn. The reason why I don't really like them is because how are you supposed to know that without, like, if I could have kept rotating this and rotating this, how did I know that was 90 degrees? Well, I'll figure something out. In class, we'll learn, okay? So don't worry too much. Oops, that was supposed to be a G. G prime. So if this is F, this is G, and this is H. G is 4, 1. And then H prime would be over 4, down 1. Okay. Number 7. The coordinates of ABCD and its image ABCD prime are given below. What single transformation could have happened just based on looking at the coordinates? So A went from being in the bottom quadrant on the left. Now it looks like it's up in the quadrant above it. Ooh, that's kind of tricky, you guys. So it looks like there are some things that stayed the same, some things that changed. Do you notice that? So let me get my highlighter. For example, look how this and this stayed the same. This and this stayed the same. This and this stayed the same. My y's didn't change. What did change was my x's. Okay, how much did they change by? And is it constant? To get from 2 to negative, or from negative 5 to 2 on a number line, that means I'd go up 1, 2, 3, 4, 5, 6, 7. So the change here is plus 7. Is that change constant? Yes. So each of these goes up 7, 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 up 7. So I know that it's going up 7, okay? Or I guess not up 7. It could be translating to the right. The x-coordinate of ABCD prime are all 7 units greater than the other corresponding x-coordinates. The corresponding y-coordinates stay the same. So I think it is a translation. So a translation, the y-coordinates stay the same, but the x-coordinates increase by 7 units. Okay, and if I'm going from negative 5, negative 2, I would say that that's like somewhere down in here, right? Negative 5, negative 2, and then now he's at positive 2, down 2. It looks like it went that way. So I'm going to say that it slid to the right. Is it okay if you were to draw that out? Definitely. Drawing that out to see it would have been much more helpful than just trying to figure it out by looking at it. Okay, last one. Draw and label a four-sided figure in the coordinate plane. Use a single transformation to draw the image of your figure and label the vertices. Then use another single transformation to draw a different image of your figure. Okay, So very simple. I'm going to do something easy. I'm going to do, I want to do a shape that's not too complicated. I'm going to do a rectangle. This is A, B, C, D. I want my rectangle to reflect across the y-axis. So first one we're going to do is a reflection. About the x-axis. So if I were to do a reflection, I'm going to use a new color, get red. If I were to reflect on the x-axis, that means C would be about here, D would be here, so this is C prime, D prime. A, let me count how many things A is. A is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6. A, and then B would be here. Okay, so there's my reflection. Okay, wow, that is a terrible, terrible handwriting for the word axis. Now I need to do another transformation. I did a reflection. I think I'm just going to do a slide because rotations don't really make me very happy. So I'm going to slide it. I'm going to do 1, 2, 3, 4, 5, 6. I'm going to say 6 units to the right. So if B was here, it is now 1, 2, 3, 4, 5, 6. This is B prime. A go over 6. 1, 2, 3, 4, 5, 6. This is now A. C over 6. I'm just going to line it up right under B. D over 6. Just going to line it right under A. D prime, C prime. Okay, so then I'm going to say I have a translation. 6 units to the right. All right. Oh my goodness, hooray, we're done. That is the end of lesson 2, which means in class we will review, and then after that we will have a quiz. All right, guys, let me know if you have any questions at all. We'll go over a bunch of the rotations in class. All right, bye.